In the last lesson, we looked at some pretty complex trinomials with variables bigger than x squared. In this lesson, we're going to look at some complex difference of squares situations. If you look at this first situation, you're going to notice the first term has an x squared and the second term has a y squared. It's okay. So when we go to factor this particular question, we kind of do the same thing as we do normally with difference of squares. We're going to take the square root of each of these things. The square root of 9x squared is 3x, so that becomes our first term in both binomials. The square root of 16y squared is 4y, and one of our factors is negative and one of our factors is positive. Now sometimes what you're going to be able to do before you go ahead and try to do a difference of squares is you're going to be able to take out a common factor. And kind of one of the hints that you know you need to take out a common factor is if you look at 3 and 27, they're not perfect squares. So if I look at this whole situation here, I know I can take a 3 out of 3 and 27, but if I look at the x cubed and the x and the y cubed and the y, well, I have a common factor of x and a common factor of y here. And you might wonder, well, how do I know with all these variables what my common factor is? Well, usually the variable with the lowest exponent is going to be your common factor. And since we have an x in both terms, and the x with the lowest exponent is just x to the exponent of 1, that's our common factor here. Same with y. We have a y in both terms, and y to the exponent of 1 is the lowest exponent, so the y becomes our common factor. So we're now left with x squared minus 9y squared. So when you divide by 3, you divide by x, you divide by y, you get this. So your common factor has to be carried down. It doesn't disappear. If we use difference of squares here, the square root of x squared is x, so that becomes each of our first terms. The square root of 9y squared is 3y. One of the terms is negative and one of the terms is positive. The last example here, we are going to be able to take out a common factor to start with of 4. Now this one's a little tricky because 144 and 4 are perfect squares, but if you can take out a common factor, you do that. We have p's and q's in the first term and r's in the second term, so we cannot take any variables out. This becomes 36 p squared q squared minus r squared. So now if we factor our difference of squares here, square root of 36 is 6, square root of p squared and q squared is pq, so that becomes our first terms. Square root of r squared is just r, one of these is negative and the other one is positive. So there we have our factors. Now if we look at a little bit of a problem situation, it says a pane of glass has the following area. It says the length and width of the pane of glass can be written as binomials in the form ax plus by, where a and b are integers. It says determine the appropriate values of a and b and hence write an expression for the length and width of the pane. So essentially what they want us to do here in this particular question is they want us to actually factor this particular difference of squares. So if we do that, square root of 49x squared is 7x. And the square root of 16y squared is 4y. One of them's negative and one of them's positive. And in this case, one of these is the length and one of these is the width. Well, the bigger of these two is the one that's being added here. So 7x plus 4y is our length and our width is 7x minus y. It says given that the length of the pane is double the width and the perimeter is 56 feet, develop a strategy to determine the length and the width. Well, if I look at this, I know that we have a rectangle in this situation. So if I look at this, my lengths are both 7x plus 4y, and my widths are both 7x minus 4y. And I know if I add all this stuff together, it's going to give me my perimeter. So I've got 2 7x plus 4y's plus 2 7x minus 4y is going to equal my perimeter, which is 56. Now if I solve this, I multiply through by 2, I get 14x plus 8y plus 14x minus 8y equals 56. So in this case, hold on, this is 14x here. I have 28x, 8y minus 8y cancels out. I get 56. So I get x to actually be, in this case, 2. Now, how am I going to find out what y is? Well, I'm going to take this particular value of x, and I'm going to have to form a second equation. It says the length is double the width. So the length is 7x plus 4y, and that equals twice the width. So if I now look at this equation, if I expand it and I simplify it, this gives me 14x minus 8y. If I move everything to the right side, I subtract 7x and I subtract 4y, I get 7x minus 12y is equal to 0. Well, I know x is 2. So if I substitute 2 in for x, I can solve for y. So this gives me 14. If I subtract 14, I get 12y. Now if I divide by 12, I'm going to get y is negative 14 over 12. Hold on there. This is minus 12y. So this is going to give me positive negative 14 over negative 12, which is going to give me 7/6 if I simplify it. So now I have an expression for x and I have an expression for y. So how do I find the length and how do I find the width? Well, we know back up here our length is 7x plus 4y. So if we take 7x plus 4y, I know that my x value is 2 and I know my y value is 7/6. And if I solve for the length, if I actually calculate this out, I get 18 2/3 feet for the length. If I do the same thing with 7x minus 4y, I get 7 times 2 minus 4 times 7/6. So for my width, I end up getting 9 1/3 feet. So I can actually use some equations I set up to help me solve some situations here. Okay, we've got a couple more examples to look at. These aren't really that difficult, they're just a bit different is what I would say. Again, we've got something where we've got an exponent higher than 2 in this case. If we look at this, this is a difference of squares. K to the 4th, if you take its square root, is k squared. And the square root of 1 is 1, and one of these is negative and one of these is positive. Now if you look at k squared minus 1, what you're going to notice is that's a difference of squares also. So this can factor down into k minus 1 and k plus 1, and we also have k squared plus 1. Just like previously when we did quadratics, sometimes what can happen is you can take out a common factor to start with. In this case, we can take out a common factor of 5. And what we're left with is we're left with 16a to the 4th minus x to the 4th. So now if I start factoring this, square root of 16a to the 4th is 4a squared. Square root of x to the 4th is x squared. Now, this middle term, 4a squared minus x squared, is also a difference of squares. So it can factor down to 2a minus x, 2a plus x, and don't forget this other factor that you had. It's still part of our solution. The last couple of examples we're going to look at is where we sometimes have a binomial in our question that we're going to be factoring. It doesn't necessarily make this any harder, it just makes it different. The square root of a squared is a. Now the square root of b minus c squared is b minus c. Now we're going to leave that in brackets and you'll see why in a second. One of these is positive and one of these is negative. Now, If we distribute the positive 1 to both of these terms, it doesn't change it. But if we distribute the negative 1 to both of those terms, it is going to make this negative b and positive c. So you've got to distribute that. Here, we're going to end up with two binomials when we factor this. We're going to end up with 2x minus y and x plus y. One of these is positive and one of these is negative. So if we look at this first situation, 2x plus x gives me 3x. Negative y plus y, well, that cancels out. The next situation, 2x minus x is going to give me x. Now negative y minus y is going to give us negative 2y. So there you go. It's not that complicated. It looks scary at the beginning. Don't let it scare you. You just use your rules of factoring difference of squares for that.